Hello everyone, a very good evening to all. Myself, Vivekananda Naik, I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. I welcome you all once again for this 11th interaction session on the course Experimental Physics 1, which is being float this July 2025 session by NPTEL with course code NOC25 PH51. So today we will be solving a few problems that will be based on week 11 course contents and the lectures that are part of the week 11 course content. Let's discuss about that. So if you if we talk about week 11 course contents, so out of 5 lectures, so 2 lectures were related to RC circuit. So it was theory on RC circuit, then experiment on RC circuit. Then third lecture was magnetic field along the axis of a circular coil, magnetic field along the axis of a circular coil. Then experiment regarding that concept. Then the last one was study of induced EMF. So the concept of induced EMF of an induction coil. So all these concepts were covered in this week's lecture. So we will be solving a few problems. But before that, let's discuss briefly about the concepts that has been taught in this week. So if you talk about the RC circuit, so RC circuit is basically a circuit that contains one resistor and one capacitor. They can be connected in series and also they can be connected in parallel, and they are mostly or most widely used in filtering, timing, and signal processing applications. So let's draw a series RC circuit. Suppose this is resistance, then this is capacitance, and there is a voltage source. So this is a voltage source that has been connected. This is R, this is C, and the current is flowing in this direction. So suppose this is the voltage, the supply voltage Vs. So the voltage drop across R, this is VR, and the voltage drop across C is Vc. So V will be VR plus Vc, or V. So voltage drop across voltage drop across the resistor across the resistor is V is equals to IR, and the voltage drop across capacitance, it is given by Q by C. But for time dependent part, it will be V by R e to the power minus T by RC. So this is the when the DC voltage is applied. Similarly, the charge. What about the charge? So the charge as a function of T is given by CV 1 minus e to the power minus T by RC, and similarly the voltage across the capacitor, that is VC, it will be V 1 minus e to the power minus T by RC, where this RC is called as tau, which is time constant. So this is the case of charging of a capacitor. So this is the formula for charging. So the capacitor stores energy. So when we disconnect the circuit from the supply, so the capacitor discharges. So what will be the uh, voltage? So the discharging voltage Vc as a function of t, it will be V0 e to the power minus t by Rc. So similarly, the circuit can also be used as parallel circuit. So if it is parallel, this is discharging. Then talking about the parallel circuit, here Z will be R square plus 1 by omega c square root over. This is the case of this parallel circuit, and this phi with the phase angle to be minus 1 by omega Rc. So the applications are low pass filters, high pass filters, timing circuits, and integrators are differentiated. It is due to the voltage because uh, voltage is dq by dt for a capacitor. So depending upon the nature of the capacitor, it is used for different applications. Now, if you talk about uh, the magnetic field along a current carrying coil, magnetic field. If you discuss the concept of the magnetic field, so it is again based on the concept of Biot-Savart law. Biot-Savart's law, and what it basically says. So, according to the Biot-Savart's law, it gives the expression for the magnetic field produced in a point due to a small current element, that is small wire carrying current and all of the things. So how it is expressed? So it is dB is mu 0 by 4 pi I dl vector r cap divided by r square. So here what is dl vector and r vector? So suppose this is a, a current carrying element and current is flowing along this direction. So this is also the dl vector, this element, and suppose this is point P and this is angle theta and this is r cap, and the distance from this point is r. So depending upon the situations, we can calculate the magnetic field, and then integrating over the quantity dB, we can calculate the total magnetic field at a point due to different current elements that we'll discuss in some problems. Similarly, if you talk about the induced EMF, it is based on the concept of electromagnetic induction. Electromagnetic induction, that is the induced EMF is proportional to d phi by dt, and it why it is negative sign here, because the induced EMF opposes the cause that produces it. So now let's discuss a few problems uh, based on these concepts that we discussed briefly now. So question number 1, it says in electromagnetic induction, the induced EMF in a coil is independent of, options are option A, change in the flux, option B, time, option C, resistance of the circuit, and option D, none of the above. So the question says the in electromagnetic induction, the induced EMF in a coil is independent of. So on which factor the induced EMF is not dependent. The options are option A, change in the flux, option B, time, option C, resistance of the circuit, or option D, none of the above. So I'll give you a few minutes and then we will discuss which one will be the correct answer. So if you so we just discussed the concept of electromagnetic induction. So the induced EMF is proportional to the rate of change of the flux. So since the rate is coming into picture, so EMF which E is minus d phi by dt. So or we can say here if n is the number of turns. So the it is dependent on change in flux and it dependent on time. So it is if you see it is not dependent on the resistance of the circuit. So the correct option will be option C, that is the resistance of the circuit, and none of the above. Since we got the correct option, so it is again not correct. So it is independent of resistance of the circuit. I hope this clears your doubt. Now we move to question number 2. Question number 2 says the magnetic flux linked with a coil is given by an equation phi equals to 5t square minus 3t plus 4 in Weber. The unit of magnetic flux is Weber, and the short form is WB. The induced EMF in the coil at t equals to 5 second is, options are option A minus 47 volt, option B 27 volt, option C minus 33 volt, and option D minus 15 volt. So these are the options. The magnetic flux, because since we know the rate of change of flux produces EMF, and so here the flux is changing with time, and the expression is given as 5 t square minus 3t plus 4. So this is the expression for the flux at a particular time, and we need to find out the EMF at t equals to 5 seconds. So I'll give you a few minutes and then we will discuss. So as we know, the EMF is given by the formula E equals to minus d by dt of phi. So minus d by dt of phi. Phi is 5 t square minus 3t plus 4. That implies this is minus of 10t minus 3. That implies minus 10t plus 3 at t equals to 5 second. E is minus 10 into 5 plus 3. That implies E is equals to minus 50 plus 3, which is minus 47 volt. So the correct answer is option A, minus 47 volt. Let's move to the next question. The question says, in a coil of area 20 centimeter square and 100 tons, there is a magnetic field directed perpendicular to the plane of the coil, and it is changing at a rate of 0.5 Tesla per second. The resistance of the coil is 5 ohm. The magnitude of the current in the coil will be. Options are option A 0.5 ampere, option B 0.1 ampere, option C 0.05 ampere, and option D 0.02 ampere. So there is a coil of area 20 centimeter square and number of turns N is 100, and there is a magnetic field directed perpendicular to the plane of the coil. So the magnetic field is perpendicular to the plane of the coil. So suppose there is a coil and it is perpendicular to the plane of the coil. So suppose this is a coil, it is perpendicular to the plane of the coil, and is changing at a rate of 0.5 Tesla per second. So the rate of change of the magnetic field is 0.5 Tesla per second, and the resistance of the coil is given. So the resistance of the coil is also given. This is 5 ohm, and we need to find out the magnitude of the current in the coil. So options are option A 0.5 ampere, option B 0.1 ampere, option C 0.05 ampere, and option D 0.02 ampere. So these are the four options. I'll give you a few minutes. This question is a bit different from the questions that we have solved today, and then we will discuss what will be the correct answer. So if you remember the first question that we solved today, so it was related to the concept of electromagnetic induction, and in that question it was discussed that the induced EMF is independent of the resistance of the wire. But why here the value of resistance is given? Because here we need to find out the current. So for current we need to know the value of the resistance. So first let's calculate the induced EMF, and then we will calculate the uh, current. So what is the induced EMF? So induced EMF, it is again the, so since here it is the magnitude of current. So here magnitude of current we need to find out. So we will take positive value. So here, so the induced EMF, we will take only positive value, which is N d phi by dt. What is phi? Phi is flux, is not it? So here it is uh, mm, given in a coil of area 20 centimeter square and 100 tons. So 20 centimeter square and 100 tons, and the uh, rate is 0.5 Tesla per second. So here if you see, so 5 Tesla per second, Tesla and Gauss, they are the unit of magnetic field. So dB by dt is given. So dB by dt it is given, it is 0.5 Tesla per second, but the value of flux is not given directly, so you need to calculate. So what is the value of flux? So phi is b into a, so ba cos theta, so cos 90 is 0. So if you do, so here also one more thing you need to see. So here it is given perpendicular to the plane of the coil. So when it is perpendicular to the plane of the coil, so we know the area vector is also perpendicular to the plane of coil. So both b vector and a vector, they are along same direction. So theta is 0 degree. So cos theta is 1, so it will be b into a only. So flux will be ba cos theta, that implies ba. So what is the value of flux? So flux phi is, or we can say d phi by dt is d ba by dt. So since area is constant, area is non-changing, so we can say a dB by dt. So you will use this formula. So EMF induced is n d by dt of ba, or we can say n a dB by dt. So n is 100 into a is 20 centimeter square. So in order to convert into SI units, we will convert it into meter. So it will be 20 into 10 to the power minus 4 into dB by dt. dB by dt 0.5 Tesla per second. So it is 0.5. So this will be the value of induced EMF. Now what will be the current? So the induced current will be, I will be EMF by resistance. So here if the uh, induced EMF is independent of the resistance of the coil, but in order to calculate current, we need the value of resistance. That's why the value of resistance is given in this question. So what is the value of induced current? So it will be 100 into 10 to the power minus 4 into 20 into 0.5 divided by R. R is 5, because it is given 5 ohm. So if you calculate, it will give you 0.02 ampere. So it is 0.02 ampere. So the correct option is option D, 0.02 ampere. Here no information about direction is given or direction is needed. So we are only calculating the magnitude of the induced coil. So now we move to question number 4. So question number 4 says a coil having an area 2 meter square is placed in a magnetic field which changes from 2 Tesla to 4 Tesla in an interval of 0.2 second. The magnitude of the EMF induced in the coil will be option A 5 volt, option B 10 volt, option C 20 volt, option D 7.5 volt. So here the area is given. The area, it is given as 2 meter square, and here the magnetic field changes from 2 Tesla to 4 Tesla in an interval of 0.2 seconds. So magnetic field is changing from 2 Tesla to 4 Tesla, and what is the time interval? The time interval is 0.2 seconds. So from this we need to find out the rate of change of the magnetic flux, and then we need to find out the EMF induced. So what is the EMF induced? That we need to find out. So the options are 5 volt, 10 volt, 20 volt, and 7.5 volt. So here again the magnitude is given, so you don't need to consider the sign convention, and the options are given. So I'll give a few minutes and then we will discuss about the correct option. So again we know the formula. The induced EMF, it is given as E mod equals to d by dt of phi, and phi is B into A, so it is A dB by dt. So what is dB? dB is changes from 2 to 4, and dt is 0.2 second. So that implies E mod equals to A into 2 by 0.2, and again area is 2 meter square, so 2 into 2 divided by 0.2, so it is 20 volts. So the correct option is option C, 20 volt. It was a pretty straightforward question. Now we move to question number 5, which says in the given diagram a RC series circuit is shown. So now this comes to the concept of series RC circuit. So as you can see here, there is a RC series circuit which is shown in the figure, and the voltage applied is 10 volt. The capacitance of the capacitor is 5 microfarad, and the resistance is 2 mega ohm. So after the switch is closed, the charge on the capacitor after 10 seconds. So as we know, for a DC signal, the capacitor charges. So the total charge developed on the capacitor after 10 seconds, that we need to find. So the voltage, the supply voltage is 10 volt, capacitance is 5 microfarad, resistance is 2 mega ohm. So what will be the charge? And that also after 10 seconds. So that we need to find out. So options are option A 31.6 microcoulomb, option B 24.7 microcoulomb, option C 44.5 microcoulomb, and option D 17.8 microcoulomb. So these are the four options. I'll give you a few minutes to solve this question, and then we will discuss which one will be the correct answer. As we have already discussed, the charge on a capacitor is given by Q equals to Q0 1 minus exponential minus T by RC. So what is Q0? So it is the initial charge. So Q0 is C into V. So 5 into 10, this is 50 microcoulomb, because the capacitance is 5 microfarad. So it will be 50 microcoulomb. So it is 50 1 minus e to the power minus T by RC. So 50 1 minus e to the power minus, so t is 10 second divided by RC. R is 2 mega ohm, and so R is 2 mega ohm, 2 into 10 to the power 6 into 5 into 10 to the power minus 6. So 6 into minus 6 get cancelled out. So it is 10 by 10 to the power 1. So is it? Yes. So it is 10 second. This is 5 microfarad. This is 2 mega ohm. So 5 into 2 10. So 10 10 to the power. So it is 10 by 10. So it is 50 into 1 minus e to the power minus 1. So it is 50 1 minus 1 by e. So what is the value of 1 by e? So 1 by 0.36. So it is, so Q is 50 1 minus 0.36. So 50 into 0.64. So 0.64 into 50, it is 32. So it is 32 microcoulomb. And if you see the options, it is 31.6. So I think if you take the value to higher numbers, like it is 0.367, then it will be 50 into so 1 minus 0.367, which is 0.663, 50 into 0.633. So 0.663 into 50 is 31.65. 31.65. So the correct answer is 31.6, option A. I hope this is clear to everyone. Now we move to question number 6. So question number 6 says a battery is connected between 2 points A and B on the circumference of a uniform conducting ring of radius r and radius r, small r and distance capital R. One of the arcs AB of the ring subtends an angle theta at the center. The value of the magnetic induction at the center of the ring due to the current in the ring is, options are option A direct proportional to theta, option B inversely proportional to theta, option C direct proportional to pi minus theta, or option D 0 for all values of theta. So this is an important question from the point of view of your exam also. So I'll give you a few minutes and then we will discuss in details what will be the correct option. So here now let's discuss this problem. So it says a battery is connected between 2 points A and B on the circumference of a uniform conducting ring of radius R and resistance R. So this is a conducting uniform conducting ring. Suppose these are the 2 points A and this is B. So the radius is, suppose this is the center, this is R and the resistance is capital R. So one of the arcs AB of the ring subtends an angle theta at the center. So suppose this is the angle theta at the center. The value of the magnetic induction at the center of the ring due to the current in the ring. So suppose this portion AB subtends an angle theta and the length, suppose this is L1. So this is L1, this is L2. So that L1 plus L2 equals to 2 pi small r, and it is connected to a wire. Sorry, suppose this is the connection and this is a voltage supply that is given. This is B. So this is the direction of the current. So this is I, this is I1, this is I2. Again it will come back as I2, then it is I, that will again come back. So here at this point it will be, so I is I1 plus I2. So current is flowing like this. So now if you talk about the resistance, so we know the resistivity is independent of the length. So what will be the resistance R1 for this portion L1? So L1, suppose the resistance is R1, for L2 resistance is R2. So now what is R1 and R2? So R1 is rho L1 by A, R2 is rho L2 by A. So they are those, if you see these two, they have the same initial point and final point. So since the current is getting splitted, so these two lengths L1 and L2, they are in parallel. So what will be the value of voltage? So voltage drop across both the portions will be equal. So R1 and R2, they are parallel. So V1 equals to V2. So V is equals to IR. So I1 R1 equals to I2 R2. So I1 R1 equal to I2 R2, or we can say I1 into R1 is rho L1 by A equals to I2 into rho L2 by A. So the rho A gets cancelled out. So it will be I1 L1 equals to I2 L2. So this is the relation. Now if you use the concept of Biot-Savart's law, then what will be the field due to portion L1? So B1 due to portion L1, it is given by B1 equals to mu 0 I1 divided by 4 pi L1 by R. Then for B2, that is the length L2, B2 equals to mu 0 I2 by 4 pi L2 by R. So this is the expression for two magnetic field for the two components. So now since L1 I1 equals to L2 I2, then B1 equals to B2. As you can clearly see here, it is L1 R1, it is L2 I2. So B1 equal to B2. So the net field at the center is 0, and the current current flows in opposite direction, and the current flows in opposite direction. So net field at the center, net field at the center is 0. So here the value of the magnetic field at the center of the ring, the magnetic induction at the center of the ring due to the current in the ring. So it is 0 for all values of theta. The correct answer is option D, because the current flows in different direction and the product of current and length is same for both, because resistance is inversely proportional to, so resistance is right proportional to L. So resistance is more, so current will be less. So the product of L1 I1, L2 I2, they will be equal. That's why the value of magnetic field will be equal for both the portions, and since the current is opposite, the direction of the magnetic field will be opposite, because it is due to, so according to the direction rule, so the direction is opposite because the direction of the current is opposite. So the net magnetic field at the center will be 0. So the correct option is option D, this one. Now we move to question number 7. Question number 7 says an arc of a circle of radius r subtends an angle 60 degree at the center. It carries a current I. The magnetic field at the center will be. So there is an arc. So this is the arc, and this is 60 degree, and it carries current I. So current I it is carrying. Then the magnetic field at the center. So the magnetic field at the center of this is O. What will be the value of magnetic field at O? The options are option A mu 0 I by 8R, option B mu 0 I by 4R, option C mu 0 I by 12R, and option D mu 0 I by R. So these are 4 options. This question is a bit simple, but the concept of the question is pretty similar to the previous question. So I'll give a few minutes to solve this question, and then we will discuss about the correct answer. So we know according to the concept of Biot-Savart's law, for a current element, the magnetic field is given by mu 0 by 4 pi I dl vector cross r vector by r cube. So here r vector and dl vector, all these are perpendicular because this is I and this is r. So r vector and this dl vector, so this is dl length, so they are perpendicular. So dl vector is perpendicular to r vector. So what will be the magnetic field? So B will be mu 0 I by 4 pi 1 by r square dl. So mu 0 I by 4 pi, this is L, so total length is L, 1 by r square L. So mu 0 I divided by 4 pi. Sorry, there are some unwanted background noises, so that's why I had to stop in between. So now mu 0 I by, so this is 1 by r into L by r. So since it makes an angle 60 degrees, so L by r will be pi by 3. So if you put the values, so B will be mu 0 I by 4 pi into pi by 3 into 1 by r. So pi gets cancelled out, so it is mu 0 I by 12 bar answer. So it is mu 0 I by 12 bar. Or you can solve it in another way. So another way, so we know the magnetic, suppose this is a complete circle, so the magnetic field induced at the center of the oil, it is given by the formula B is equals to mu 0 I by 2r. So since it makes an angle 60 degree, so 60, so it complete is 360 degree, so 60 degrees 360 by 6. So this portion, suppose this is B1, so B1 will be 1 by 6 of mu 0 I by 2r, because it is equally distributed and current is flowing, equal current is flowing through all the wire, so it is the total overall length L is L by 6, so it is will be 1 by 6, so it will be mu 0 I by 12 R. Again, this is another way to solve it. Now we move to question number 8. So question number 8 says a circular coil of radius A carries an electric current. The magnetic field due to the coil at a point on the axis of the coil located at a distance r from the center of the coil, so that r is greater than A varies as options are option A proportional to 1 by r, option B proportional to 1 by r square, option C proportional to 1 by r cube, or option D proportional to 1 by root r. So a circular coil of radius A carries electric current. The magnetic field due to the coil at a point on the axis of the coil located at distance r from the center of the coil, such that r is very greater than A. So this is a circular coil and radius is A. And the magnetic field of the coil at the point axis. So this is an axis and this is a distance r. Sorry, this is r from the center of the coil. So this is not r, this is r. So this is the point P. So what will be the, so for r very greater than A, what will be the dependence of B on r? That we need to find out. So I'll give you a few minutes and then we will discuss what will be the correct answer. So if we discuss, so according to the formula, the magnetic field for a at a point which is at a distance r from the center on an axis and the radius of the circular coil is A, it is given by mu 0 by 4 pi 2 pi I a square divided by a square plus r square to the power 3 by 2. So this is the formula. So when r is very greater than a, then a square plus r square, it will be nearly equals to r square. So a square plus r square will be equal to r square. That implies b will be mu 0 by 4 pi 2 pi I a square divided by r cube, because r square divided by 3 by 2, it will be r cube. So uh, it, so b varies as 1 by r cube. So the correct option is option C, which is proportional to 1 by r cube. So now we move to question number 9. Question number 9 says a 5 microfarad capacitor is connected to 200 volt battery through a resistance of 0.4 mega ohm. Calculate the charge on the capacitor after 6 seconds. Again, this question is pretty much similar to the question that we had already discussed related to the concept of RC circuit. So the options are option A 276.5 microcoulomb, option B 705.23 microcoulomb, option C 950 microcoulomb, and option D 480 microcoulomb. So these are the four options. I'll give you a few minutes to try to solve this question, and then we will discuss. So this type of question we had already discussed. So we know Q is given as Q0 1 minus e to the power minus T by Hc. So what is Q0? Q0 is 200 into 5 microfarad. So it is 1000 microcoulomb or 1 millicoulomb. And what is Q? Q is Q0 1 minus per minus T by Rc. Uh, T is 6 second and RC is 5 into 10 to the power minus 6 into uh, 0.4 mega 0.4 into 10 to the power 6, so it is 2.0. So it will be 1000 into 1 minus exponential minus 6 by 2. So it is 1000 into 1 minus 1 by EQ. So it will be 1000 into 1 minus 1 by 0. So it is 1 minus 0.05, which is 950 coulomb, microcoulomb. So the correct option is option C, 950 microcoulomb. Now we move to question number 10. So question number 10 says a capacitor of capacitance 2 microfarad is first fully charged by a battery of 10 volt and then discharged through a 5 mega ohm resistor. Find the time at which its charge falls to half of the full charge. So options are option A 2.97 second, option B 3.86 second, option C 6.93 second, or option D 4.21 second. So this question is pretty much similar to the previous question, but here the time constant we need to find out, because we need to find out the time value. So we will use the concept of time constant, because we need to find the time value for which the charge is half of the initial charge. So Q is Q0 by 2. Then we can calculate the value of T. So I'll give you a few minutes and then we will discuss what will be the correct option. So if we solve it, so this is the expression q is q0 1 minus exponential minus t by rc. So half means we can write q equal to q0 e to the power minus t by rc. So this q will be q0 by 2. Then what is the value of t? So q0 by 2 equals to q0 exponential minus t by rc. That implies 1 by 2 equals to exponential minus t by rc, or ln 1 by 2 is minus t by rc, or ln 2 is t by rc, or t is ln 2 into rc. That implies t equals to 2 into 5 into ln 2, which is 2 into 5 into 0.693, it is 6.93 second. This is second, and so the correct answer is 6.93 second, which is option C. So after 6.93 second, the so after 6.93 second, the total charge uh, on the capacitor will fall to half of the full charge. So with this, we come to the end of today's interaction session. Uh, I will like to thank you all for joining in this session and for registering this course. So I hope the questions that we have discussed today will help you in solving your assignment problems, this year's assignment problem, as well as for preparation of your exam. With this, uh, that's it from my side. Thank you.